let's go ahead and get right into it. This time we got backspace string compare. So you given two strings s and t, return if they are equal when both are typed into empty text editors. The octothorpe, commonly the hashtag, means a backspace character. So we got example 1 here, s is equal to ab octothorpe c, t equals ad octothorpe c. Output is true. True because both s and t become ac. Okay, got it. So when we see hashtag, we subtract the previous integer or string. Character, character. So we have this little hash right here. We need to put something in our code that if that's the first character, then do nothing. Right off the bat, I'm thinking of using a stack data structure. Let me give you a visual representation of how a stack works. So a stack is kind of like exactly what it's called. Stack is like a bucket. So then if we put an object in the bucket, let's say we'll put the character A, right? We put it at the bottom of the stack. Then we're going to insert character B into the stack. Now B is in the stack. And then we're going to insert element C into a stack. Now if I wanted to reach in and pull out of the stack, I can only pull out C. I cannot pull out B and A. In order for me to get B and A, I would have to pull out C, and then I could get to B. If I wanted to pull out A, I'd have to pull out C, and then pull out B, and then pull out A. Alright, so that's how a stack works. I'm thinking we use that. Let me pull out Java Stack API. Little reference to all the methods. So the stack only has about 5 methods. We got empty, tests if the stack is empty. Peek looks at the object at the top of the stack without removing it from the stack. Then we got pop, which removes the object at the top of the stack and returns that object as the value of the function. So this is what I'm thinking we're going to use when we see an octothorpe, and then we're going to remove that previous element that's in the stack. And then push is an item. So for the structure, I'm thinking we are going to iterate through each character in the string. If octothorpe is the next element, then we're going to remove the top element in the stack. I think that's it. Seems kind of simple for the most part. So let's go ahead and initiate our stack. We're going to use characters. Stack equals new stack, I believe. I think that's correct. I need to do 2 stacks actually. One for S and then one for T. Equals new stack. Stack 1 for string S for string T. We want to limit our operations as much as we can. So I guess we'll just make 2 for loops. I is less than S dot length I plus plus iterate through string S. If stack1 dot is empty and S dot character at I equals the octothorpe, then this is where we'll do nothing. Well, that seems like here we would do stack1 is not empty. Then we'll do something. Then we'll do stack1 dot pop, and this removes the previous element if character, I can't even type today, character is the octothorpe. Cool. Else stack1 dot push s dot character at. Cool. And then I guess we'll have the second for loop to do the exact same thing, but with stack 2. We want to change that to 2, and then 2. So yeah, here we'll have if stack is not empty and s dot character is the octothorpe, then we'll remove the previous element. Else we're going to go ahead and push that character to the stack. Okay, so for here we're going to basically iterate through both the stacks at the same time, and if they pop the same elements, then we'll return true. We're going to do a while statement. While stack1 dot while stack 1 is not empty, and while stack 2 is not empty. Then we'll do if blank if stack 1 dot pop equal to stack 2 dot pop. Not here. We'll do not equal to. So if they do not equal each other, then we'll return false. Then if this happens to get all the way through and they do equal each other, here we'll return true. So that gets to the end of the statement. Let me go through. We can delete this structure. We got the idea now. Character, and this should be int. Duh. This should also be int. Maybe I need to do it to where it's like a method. I know for arrays you don't have to do the parentheses like that. Here I didn't put the parentheses. Lots of simple mistakes. I make a lot of simple mistakes. It's cool though. Error-driven programming right here. Okay, so here we don't want just char. We want the character object to be able to be held in the stack. Oh, look, there's a capital S. We don't want a capital S. Okay, that should be it. No more compile errors. Finished. Looks like it worked. Let's go ahead and submit. Pending, judging, wrong answer. T.length. Duh, because we want to go to the length of T, not S. Not string S, but T there. Oh, here, I forgot to change this all to T. We're still doing S.length. T.character at I, and then we have this right here. T.character at I. Of course, we're dealing with T, not S. Now I'm going to review. So we're going to add if stack1 dot size is not equal to stack 2 dot size. So this is immediately going to end the code if the size aren't the same. It would make it a little bit quicker, not having to iterate through the entire stack. Here I'm thinking we need to probably change the else if statements. If s dot character at I does not equal the octothorpe, then we're gonna push that there. We're gonna do this. We put this here just in case, so we don't have any of the octothorpes in our stack. We do that t.character at I. Okay, so I'm also seeing here that we should probably put or. That will change if one of them is empty. Then it won't return true. It'll still iterate through this anyways. So that should be the case. Should be done. Go ahead and submit. Let's see what we got. There we go, and we got accepted. Like I said, that should be O to the N growth function there. I'm not sure how we would get O to the 1. If you guys have any advice there, please leave a comment. If you guys would have solved it any differently at all, also give a holler. But yeah, that's it. That concludes the video. Tune in next time for day 10 tomorrow.